Right, so we're moving on to the little drill stand product now. So we've possibly just started doing this in the classroom, but we'll start it from scratch. So we've got a few different parts here again. So we've got a top plate, or what's called the top plate on the drawing. We've got a bottom plate. We've got some sleeves, which are the hollow bits of tube. We've got some threaded bar that goes through these, and then we've got 6 cap nuts or dome nuts, which finish the product or attach the parts together. We've got a series of holes in here that start at 2mm. The drawing says that they go up to 10, but it does tell you the things, so it's not just 2, 3, 4, 5, 6, 7, 8, 9, 10, because it's not quite there. So we've actually got a 2, 2.5, 3, 4, 5, 6, 7, 8, 9, 10. So that's the designations that the drill sizes go up in for this product. Now, the top plate and the bottom plate, then, it's pretty much the same thing. So rather than make this twice, we'll draw the bottom plate, we'll save it as bottom plate, and then we can save it again as top plate, and then we can add these bits into this bit. Really important that we do save as and not just save, otherwise we'll overwrite the file, which is the bottom plate. Obviously I've made the assembly here, so I've actually already got them all drawn, but we'll just draw them again, but I'll just not save mine, but I'll show you the process of saving just so you know. So we'll go File New. As always, we are working in that metric folder, so that's hidden within that ENUS. I know I say this in every video, but just to make sure you're getting the right one, and we want a standard millimeter.ipt. You can either click create, or in my preferred, I just double click on the actual icon itself. So that's going to load up a new file, and as always, for anything to exist in 3D, which is the window that we're in at the moment, it's first got to exist as 2D. So we need a 2D sketch, and we pick that XY plane. They're our usual 2D coordinates if you were to do a graph in maths or something like that. So I'm just going to pan my screen just to the right, because I'm going to draw in this kind of top left section. And looking at the drawing that you've got in front of you, this starts off as a triangle which has got side lengths of 100. It's an equilateral triangle, therefore all the angles are 60 degrees and all the sides are 100. So I can actually save myself a bit of time here, because if I type 100 in and then press the tab button, I can then type 60 degrees into this little bit. You don't need to do the 0, 0, just 60 would be absolutely fine. And the lines are already going black. We're already constraining that drawing as we draw. So again, if I lock this line on, I've not had to put a measurement. I've not had to put an angle there. It's an equilateral triangle. If I press that escape button, it's fully constrained. Now, if your last line that you put on goes purple, you'll just have to put a dimension on it. Now, it's going to kick me out here when I try and do this, because it already knows it. So this is not the measurement we want. That's the height of that thing from the kind of the origin point to the point at the top. We actually want an aligned measurement, a bit like this one. And to get to those, we just right click and we change that to an aligned measurement in order for a length. It's going to tell me it's going to over constrain the drawing when I try and do this. We don't need it on. It's fully constrained as it is, so I can just press cancel there, and that will do it. So we've finished everything we want to do in 2D. A little bit more difficult, I suppose, now, because we're not just working with rectangles. We've got a triangle here, so we'll go finish sketch, and we will go on to extrude. We want to give this a thickness now. Now, again, there's something written on your drawing in order to tell you how big or how thick the material is. In this case, it tells you that the top and the bottom plate are 3mm thick. So we'll just type in 3 into there, and now we've got our triangle shape, which is the rough shape we want for our bottom plate and our top plate. Now you'll notice that the corners are rounded. That's kind of for aesthetics and just to make it safe. Apologies, clicked on the wrong thing there. So we'll just go that again. Sometimes when you do this, you better to zoom in. It's just easier to click on those lines, especially if you're trying to look through your shape in order to get onto those. So we can pop those in. Now they're not 2mm, which is the default. They're actually an R5. Remember, R on a drawing is radius, so R5. And we'll press OK. So we've now got our rounded triangle in this case. And we need to put the 3 holes in there, which are going to join all these components together. So When we do holes, there's loads of different ways we could do it, and I think throughout the projects I show you different ways of doing it. My preferred method is always the one I'm going to show you now, and there is a reason for that which we'll look at when we are doing it. So I'm going to create a sketch on this surface, and then I'm going to use this tool called Point. Now I'm particularly paying attention not to lock it into a position. So if I was to hover over this curve, it finds the center point and it'll try and latch onto that little bit. Now that's not really in the right place, because that would be R5. It'd be 5mm away from the edge, and that's not what we want for ours. So we don't really want to highlight over a particular bit. So I'm going to just try and click in 3 locations, but don't attach those to anything else, because you could actually give it a constraint there which you don't want to do. So I've got 3 points on there. I'm going to press the escape key. I'm just going to press D on my keyboard. That loads dimension. It's just a shortcut. And we want to say that we want these 8mm from all of the edges. So we're going to have to do this a few times. So if I firstly do this one and say that wants to be 8mm, and then I can do it on the opposite side and also say that wants to be 8mm. And then I could do this bottom one and tell it I want it to be 8mm. From the point to the side, again, we want that at 8mm, and I'll go from this side to this side for 8mm. Now I could, if I really wanted to, I could put an 8mm on there. Same thing as doing a horizontal constraint between this point and that point. Okay, I know it's worked because I'm fully constrained. I've got all the measurements I require. So it would have worked the same if I'd put an 8 there. I've already put an 8 there, so I can just make those 2 points horizontal in this case. So fully constrained. We'll get on to the next little bit. We'll go finish sketch. Now, why do I prefer that method for doing holes? Well, if I click on hole now, automatically, apart from I've got a 5-inch hole there, so I'll just change this to 5, which is the measurement one I want. You'll notice that we now have all 3 things selected. Okay, so it's actually put a hole onto all of those points that I have got. Okay, so although this is my preferred method, okay, part of this project is to show you that when we put those next set of holes on, that actually could cause a little bit of an issue. So we'll look at that when we get to it. So we've got the holes in there. We've changed it to 5. We'll press OK, and there is my bottom plate. We've got our rounded triangle with our 3 holes kind of in the corners, which is exactly what you want. So if you compare that to your drawing on your drawing, you've got a exact copy of that bottom plate. So best thing to do would be to file, save as. We'll save that one as bottom plate. I'm not going to do it because I've already got it. And then you can press save, and that'll save you the bottom plate. Now, rather than having to do all of that work again for the top plate, what we might as well do here is go file, save as. Again, I'm not going to save mine just because I've got it. But if you now save that as top plate, okay, your file up here where mine says part 2, yours will now say top plate in there. So you've got the bottom plate saved. You now need the to do a bit more work on the top plate to put this series of holes in there. Now I'll just start working on this one. I've not saved it. I've already got one called top plate and bottom plate, obviously. So as long as you're now working on top plate, and just make sure where it says part 2 it does say top plate, otherwise you're going to overwrite your bottom plate or whatever else you've called it. I'm going to do another sketch on the front surface of this shape itself. Would it matter if I was on the back of this cube? No, I could spin it around. I could have done a sketch on the back. It would make no difference. Now what I've got there is I've got a series of holes. So I've now got 10 holes that I'm going to put on there. And again, my preferred method would always be to use points. So I'm going to just place in the 10 points. Okay, I'm trying to keep those 2 horizontal as I'm doing it. I'm going to try to keep these next 3 horizontal and the middle one vertical with that top one as I go through. So I'm roughly just putting these into position. Okay, there's nothing set, and I don't want to lock it onto this one. I'm just going to move slightly to the side. Okay, could cause me a little bit of an issue later on if I try and do that. Now, the easiest things to dimension so far are the heights above this bottom edge. So all your measurements come from that bottom edge. We've got the top one at 60. We've got these ones at 48. We've got these ones at 33. And we've got these at 18. So from the bottom line to the top, I can now just pop all of those into position, and you'll notice that as you try and draw this, you'll not be too far away from the measurements that you require. So I was just a little bit under 60 there. I'm just a little bit under 48 in that case. These ones might be a little bit lower than 33. Yep, that's 29, so I'll just change that to 33. And then we've got these bottom ones, which are going at 18. Now, we've only at the moment set the heights of this first, or these first 4 points that we've touched onto there. So again here now, where I've got a double one, I could just set a horizontal constraint, and both of those are now at 48. And in this next case, these are going to be at 33. And these are going to be at 18. So we'll just put a horizontal constraint, and we notice it's going down by 1 every time on our dimensions required for this case. Now the 2 points here, they're actually on the middle line or the centre line of the shape, and we could, if we wanted to, pop a centre line in. Now the problem with doing a centre line for this, it'll do something a little bit strange, and that'll, when you do a dimension, it'll try and dimension it either side of that centre line. So the best thing to do here would be to pop a construction line in. So either from the dot at the top or the hole in the middle of this one. I'll just go from this one, seeing as I already located it, and I'm just going to drag a construction line down. Now to get that, I've clicked on line, and I've clicked on this orange pipey looking symbol just here. It's called construction. Now a construction line will not add a measurement to my drawing. Okay, so I've still got 10 dimensions there, even though I've put another line on, which is not to the end. It is purely there to assist me as I am drawing. So we'll just now add some vertical constraints to those points and to somewhere on that. I'm just using the dot on the top. Again, I could have used the dot here. If I can pick up the centre point of that circle, I could have done it to that as well. I could have done it to the dot at the bottom. It doesn't really matter in that case. We now see on our drawings that we've got a distance between the points. So in the case of this top one, they're actually at 20 millimeters. So the set here and the set here are really, really close. Okay, it's all governed by those measurements that I'm going to put on a little bit later. So in case these ones are at 20. I've got these ones which are at 36. And I've got the outer bottom two which are at 50 on the drawing, and you'll have got a drawing in front of you so you can follow this quite easily. Now you notice they're not symmetrical yet, but we'll cover that in a moment. And we've got these bottom two which are at 18. So when we try and put dimensions on, we don't really want bigger measurements above smaller measurements. So I'm trying to lay this out so I've got them in size order as I am going. And the last one that I need, I could put this little 9 on here, which is on the drawing. I'll show you a different way of doing that just because I can. And we've got a constraint there called symmetric. So if I point at my first point at my second point, and then say I want you symmetric about that construction line that we've put in, that will make those symmetrical. So the distance here and the distance here are identical. And we can work down as we go in the same way with all of those. So they're now set all symmetrical. So a great use of the symmetric constraint there in order to do that. I don't need to put this 9 on now. If I try and put this 9 on, it'll tell me, it already knows it is, and it'll tell me it's going to over constrain again. When it puts this on, if you click accept, you'll get the measurement on there, but notice it's in brackets. So that's what we know as a driven dimension, and a driven dimension is not one that's really needed on my drawing. So I'm just going to get rid of it. It's still fully constrained without it because that symmetric constraint has done exactly what we wanted it to do. Now again, good practice here is to try and just tidy up any measurements so we've got them nicely laid out. Again, more complicated drawings, it's way easier to follow if you haven't got all of those on. So we'll go finish sketch. Now this is the bit that's going to cause us a little bit of an issue for two reasons. Number one, if I click on hole, it's going to pick up all of those holes like it did before. So what I've got to do is I've got to actually hold the control button down on my keyboard, and then I'm going to click all the ones that I don't want. Okay, so I kind of say the one downside of doing it this method, but actually once you've got your points laid out, it automatically picks it up each time. So again, it's better to do it that way than any other way. So this first hole then, that starts at 2mm, so I'll just change that 5 to a 2. I'm going to press OK. Now when I press OK, all of these other points are going to disappear. And we've done all that work and we think, oh no, we've lost it all, we're going to have to do it again, we're going to have to do another sketch on that. We don't. Those sketch points are still held within that last feature we did. In this case, it's hole number 2. Hole 1 was these 3, and then we've got hole 2. So we're going to get a series of different hole commands here in order to do it. Now, if I want to see that sketch again, what I need to do is I need to right click on it, and then I need to click on Share Sketch. And when I share the sketch, it's now visible for other features to be placed onto it. So again, if I click on hole again, it automatically picks those up, remembering the last one that I did. But again, hold control down and I'm going to click on all the ones that I don't want. So I'm now going to start moving up in the order of the hole sizes that I require on this particular product. So the next one was 2.5. So where is this information? This information is in that bottom left hand side of your drawing. It tells you information about it. So it's not always what's just around your drawings or your views of your object. It's sometimes you get little bits that might say note or important, and it might list some details that you need to know. So we can now go on. Now, it didn't disappear that time. You only need to share that sketch once. You'll notice that it's gone coloured again. It's not gone grey like it did. So again, just to try and show you that, that sketch is greyed out, it's faded out. It can only be used by that one. It's not shared. This one now becomes a shared sketch. It's actually outside of hole 2 now. So that's what determines that it can be used. So next little bit then is to kind of follow that procedure of a hole command with the next size hole. So the next one would be 3. The next one would be 4. Now each time you do this, you've obviously got less to deselect by holding that control button down and clicking. So the process does speed up here every time that you do one. So that was number 4. Then we've got the 5mm. Then we've got the 6. Then number 7. Then the 8mm. Then the 9. And last but not least, it'll only pick up one hole this time because it's that last one, and we can pop the 10mm hole into that particular bit. Now, because we've shared the sketch, it's always visible. Sometimes you don't want that. That's our finished part. We don't want it to have all these sketch measurements and sketch lines on it if you've put lines on it. So the easiest way to get around that is go to one of the sketch 3s, and it doesn't matter which one you go to. We're going to right click on it. I can't delete it. We do need the sketch. That's where all those hole features are coming from. But what I can do is I can untick where it says visibility, and then it will make it invisible. It's still there, but it is not visible on our part now. So we've made the bottom plate, we've saved the bottom plate as top plate, and now we've finished making that top plate. So again, here you need to make sure you do file and save. Again, we don't need to do save as, we've already saved it, so this time we can just press save in order for that to move. So there's a couple more components we need. Now we only need to make one of the next 2 little bits, and again these are relatively simple things. So we've got the sleeve, so file new, metric folder, standard millimeter.ipt. Quickest way of doing this one is to do 2 circles. Okay, we're going to make a bit of tube. We did something very similar on the when we talked about different constraints. So we made a hollow cylinder and then a solid cylinder in order to explore that. So this is an 8mm outer diameter, and this is 5mm inside diameter. If they've gone over the top just a little bit like that, it's quite easy just to spin one round. Then we'll go finish. We'll go extrude. Now, why does it not automatically ghost in? Well, there's 2 profiles now. There's the outer profile and the inner profile. We want the outer profile. If you click the inner one as well, it'll just turn into a solid shape. So just be really careful that you're clicking that. Again, easier sometimes to zoom in especially when you're making more complicated things. And again, by default, extrude is always going to give you the 10, but we want to change that to 25. And we'll just press OK. Now, I'm not setting any material properties here. This is made out of aluminium, so you could, if you wanted to, go into the aluminium and find an aluminium that you're happy with. I'm not going to worry too much because I'm not saving these. I've already made them, obviously. So there's the sleeve, and then the next bit is the threaded bar. So again, a relatively simple thing to make. So file and new. Standard millimeter IPT, start a 2D sketch, XY plane. This time we only need one circle. Okay, so we're going to do one circle and it's going to be 5 millimeters. Okay, it's an M5 times 0.8 thread. We'll go finish. We'll go extrude. And in this case, this is 43, which sounds like a weird measurement, but it's quite critical that you get that at the right measurement. Otherwise, there'll be a gap, or it'll not be long enough to thread both of your dome nuts onto. So what do we need to do here? Well, we need to thread the outside of it. It is threaded bar. It's going to be threaded all the way along. And what we've just got to make sure here is that we're selecting the right one. So here we use isometric profiles here in the UK. So we'll click on that one. It's already picked up the size purely because we made it 5 millimeters. And designation wise, I can get coarse thread and I can get fine threads in M5. So again, here on our drawing it says M5 times 0.8. Don't worry about the class, and Inventor does give the option to do right hand or left hand threads. In our case, it's a right hand thread. We did this on the depth gauge, although we did have to not do it as full depth. So we don't need to. We're doing this all the way like it is on your drawing, so we can just press OK in that little bit. Now it would be slightly nice once we've cut this just to chamfer these edges a little bit. So I'll click on both the edges, and again we've got a 0.5 millimeter chamfer. We've just taken the sharp edge off those bits where we're going to cut it. There's just lengths of bar that you'll cut here in order to make the item. So there's my threaded bar. Again, I've not particularly picked any, but this is going to be stainless steel threaded bar we use. So if we really wanted to, we could pick stainless steel. I think we get a couple of options of semi-polished and satin brushed here. Again, it is polished stainless steel bar that we use in order for the threaded bar that we have. So that is all of the parts made. Even though we need 3 sleeves and we need 3 bits of threaded bar, we don't need to make it 3 times. We can just pull those into our assembly 3 different times. So what we'll do is I'll end this video here. I'll do another video on the assembly so that you can continue to make the actual item.